Before we jump into the actual hands-on work of a recording session, let's go over some of the basic terminology we'll be using as we explore the components that make up a modern recording system. We'll assume that you already know the details of the instrument you play and the gear you use as a musician, and that you're familiar with the standard functions of your computer and its peripherals. We'll deal with those in more detail as we use them on an actual recording session. For now, let's take a quick look at the terms and tools that are unique to the recording process. Let's start with the two fundamental types of audio reproduction: analog audio and digital audio. Both involve electronic conversion processes, meaning that a sound you produce has to be converted into something else before it can be reproduced by a speaker system. In analog audio reproduction, a sound or vibration is captured by a transducer, a microphone or a pickup, and converted into an electrical signal. This signal contains a copy of the original sound, which can be very similar sounding or analogous reproduction of the sound, depending on the quality of the transducer and electronic equipment. That analog electric signal can then be processed in several ways. It first needs to be amplified by a preamp to make the signal stronger, and then it can be further manipulated electronically before it's sent to a speaker or a recording device. All electronic sound recorders were analog machines until the personal computer enabled digital audio recording to become affordable and commonplace. Digital audio allows for a whole different kind of processing after the sound is captured and before it's sent to your speakers. This method is much more precise and makes copies that are practically identical to the original signal. This is because the signal is converted to computer data that can be edited in an unlimited number of ways to produce audio that's more like a clone than a rough copy of the original signal. This conversion is done using an analog to digital or A to D converter, which is simply a device that takes millions of measurements of the incoming signal and stores all that information in a computer's RAM or on its disk drive. The sound is played back by reversing the process and sending the data through a digital to analog or D to A converter and onto an amplified speaker system. Audio interfaces come in all different shapes and sizes, from this relatively inexpensive entry-level unit with just a single input and two outputs, to a more sophisticated multiple in and out unit used in a professional studio, like these. The process of measuring the incoming electronic signal is called sampling. Every A to D converter operates at a certain sample rate and bit depth, which correspond respectively to how many and how big these measurements are. This combination of sample rate and bit depth dictates the resolution of the recording system. The higher the resolution, the more precise the measurements are, and thus how much the recorded sound is like the original sound. Digital audio has been a monumental advancement in the reproduction and shaping of audio. However, the quality of your finished digital audio recording depends on many factors, including a listener's personal preferences and taste. For example, today many people still prefer the sound of vinyl discs to the same recording on a compact disc or digital download. But there's no question that digital recording made high-quality, pro-level audio tools much more affordable and available. The tool that is most essential for recording is a software known as a Digital Audio Workstation, or DAW, often pronounced DAW. The DAW, in its most common current form, can handle all the audio processing that used to be handled by a mixing console and multitrack tape recorder. However, although the classic multitrack tape recorder is all but obsolete, a hardware mixer is still a desirable component of a recording system, especially for those wishing to record a live band or ensemble for which the sound from several sources must be recorded at once. The DAW handles all of the digital audio data that comes into the computer, assigning it to various tracks, enhancing it in many different ways, and preparing it for the final output. But as we've already learned, first the live audio must be sampled or digitized. Computers have their own rudimentary A to D and D to A converters, so it's possible to record directly into your CPU or laptop if it has audio input and output jacks. However, you'll have much more flexibility and get a higher quality recording using a separate hardware audio interface, an essential tool for serious recording. Audio interfaces take several forms, but they all supply these essential capabilities: at least one or two mic inputs, instrument inputs, a preamp to boost the signal, some degree of mixing capability, and A to D converters to digitize the audio. As you are recording, the interface processes and sends the audio to the computer via USB, FireWire, Thunderbolt, or other computer interface standard. The audio interface may be as simple as a tabletop unit with one or two inputs, or as complex as a large studio mixing console with A to D and D to A converters on every channel, capable of sending 48 or more audio signals to their own independent tracks on the DAW. Interfaces also convert the data from the computer back into audio when it's ready for playback. Another component that will show up in any recording system is a power amplifier. Power amps are needed on the analog front and back ends of the process. If you're an electric guitar player, you already know about power amps, although you may just refer to it as your amp. Although an audio interface may have an instrument input, most people prefer the sound of an electric guitar through a guitar amplifier, then captured by a microphone. This can also be true for bass and keyboard amps. We'll look at how to record amps later on in the series. A power amp is also needed to drive the speakers or studio monitors you'll use throughout the recording process. Power amps were once mainly separate components mounted in an audio rack for studio and live sound work, and they would be used to power passive speakers. Today, most people prefer powered monitors, which have the amplifying circuitry right inside the enclosure with the speaker itself. Choosing the studio monitor speakers is one of the most crucial tasks in putting a recording system together. We'll be taking a look at all those possibilities in the monitors section. So to review, the primary components of a modern recording system include the analog sound source, instruments or voice, the sound capturing device, microphones, guitar pickups, the audio interface which amplifies, mixes, and converts signals to digital data, and the DAW, which allows processing and mixing of the recorded data before sending it back to the audio interface for playback. That covers the main software and hardware of a recording system. Now let's look at some of the more interesting components used to make your recording jump out of the speakers.